So getting into our trigonometric functions, the trick will just be kind of memorizing the ratios that we're looking for. So when we form an angle, we have a terminal side, we have the initial side. On the terminal side, if we draw that line extending from the origin, we have a ray that goes in a single direction for an infinite amount of length. We can pick any point on that line and use it to form a triangle with the x-axis. Note, the triangle is always formed with the x-axis. Okay? I'm not going to form a triangle with the y-axis. So we can pick any point on that line, we can form a triangle with the x-axis, and then we can use that point to discern some information about that triangle. If I have the ordered pair, x comma y, the value of x gives me the measure of the horizontal leg of that triangle, because that's how far left or how far right I went on the x-axis. So that's going to measure that x distance. The same goes for y, but it gives me the vertical distance instead. So it gives me two legs of a triangle. If I know two sides of a right triangle, what can I use to find the third side of the right triangle? I have two sides of a right triangle. What can I use to find the third side? Pythagorean theorem, which is what? Good. A squared plus b squared equals c squared. You pass. Okay? So, this right here is basically Pythagorean's theorem, just written in a slightly different way. Okay? If I have legs x and y just measures a and b. So x and y. And then c ends up being what we call the radius. That's why we use r, because we're referring to radius. Okay? So a squared plus b squared equals c squared becomes x squared plus y squared equals r squared. Same theorem, different letters. There's a lot of things, anyone that's spent a significant amount of time in with trigonometry, there's a lot of different formulas that show up that are just Pythagorean theorem written in a different way. All right? So if I were to take, and I wanted to get the radius by itself, because I know my two legs because I'm given a point, and I want to solve for radius, what can I do to get r squared just to become r? Square root. And that's how we get r equals the square root of x squared plus y squared. So this formula is just Pythagorean theorem, just written slightly different. Okay? So that's all it ends up being. Now, the important thing with radius is that it's always positive. Always positive. And as long as you do the math right on the formula, it's always going to end up positive. But just in case you make a mistake, it happens. And you end up with something negative, you need to go back and double check, because radius is always positive, because radius measures the distance from the center. So from the origin to our point, how far that distance is. Distance can't be negative, so the radius can't be negative, so the radius is always positive. But x and y can be positive or negative depending on the location in the coordinate grid. Okay? So we've got 6 trig functions that we're going to be looking at. Sine, cosine, tangent, secant, cosecant, and cotangent. Okay? For sine, cosine, and tangent, does anyone remember the mnemonic device that we can use to help remember the ratios? Okay. Now, when we look in the coordinate grid, we adjust it just a little bit. Instead of using a and b or opposite and adjacent, we use x and y and r, but the idea is still the same. So let's take that same triangle that we just had, okay, and we're looking at our angle. All right. So sine, we have SOHCAHTOA, opposite over the hypotenuse, right? So the opposite side of that angle is the y value. The hypotenuse is the radius. So our ratio, normally we think of as opposite over hypotenuse. We're just rephrasing it to the y value over the radius. Cosine is adjacent over hypotenuse. Well, now we have that adjacent side is x. R is still going to be our hypotenuse. And tangent will be y over x, or opposite over adjacent. Okay? So the idea is the same. We're just rephrasing it a little bit. Now, cosecant, secant, and cotangent are the reciprocal functions. If I know sine, I know cosecant, because all I need to do is write the reciprocal of sine. So y over r, the reciprocal is r over y. X over r, r over x. Y over x, x over y. Those are the reciprocals. Keep in mind these pairs. A lot of people want to mix them up and say that secant is the reciprocal of sine because you see the s's and you want to match those up. That's not the case. Okay? Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Okay? So let's use them. All right? There we go. So I have the terminal side of angle theta in standard position, passes through the point 815. Find the values of the 6 trigonometric functions of angle theta. Okay? So I'm given a point that my line passes through on the terminal side. So I've got this angle of rotation, I got a line, and 815 is a point on that line. So my x value gives me this horizontal leg, and the y value gives me the vertical leg. What can I do to find this last side? Pythagorean theorem. Okay? So we had a squared plus b squared equals c squared. But remember on that first slide, we rewrote it to just be the radius is x squared, the square root of x squared plus y squared. Okay? Those two formulas are one and the same, two sides of the same coin. So I can jump straight here to find my radius. I just need to plug in the Pythagorean theorem. What's my x value? 8. What's my y value? Okay? What is 8 squared? And 15 squared. You're close. 225. Okay? Add them together. Square root it. There you go. So our radius is 17. Okay, so I've got my x value, I've got my y value, and I've got my radius. Okay, so now let's find our 6 trig functions. Let's start with sine. Alright, so again, here's our angle. Sine is opposite over hypotenuse, so what side is the opposite? The y value. What's my y value? 15. Okay, so y, which is 15. Okay, what's my hypotenuse? Radius, which is? There we go, we got sine. What about cosine? So what sides are the adjacent and the hypotenuse? Okay, so my x and the radius, 8 and 17. What about tangent? Okay, what's the opposite side? 15, so y over x, 15 over 17. So there's 2 or 3 of my 6 functions. Now I need to find the other 3. I need to find their cofunctions, or their reciprocal functions. Okay, sine's reciprocal is cosecant. The reciprocal of y over r is r over y. So what's the reciprocal of 15 over 17? 17. So I know sine, flip the fraction, boom, there's cosecant. Cosine's reciprocal is secant. which is r over x. So what's secant of theta? 17 over 8. And tangent's reciprocal is cotangent. X over y. So what's cotangent of theta? 17 over 15. And if you're asking yourself, really, is that it? Yes, that's pretty much it. Okay, we're just writing the ratios. We're going to use these ratios later to find angle measurements. We're just writing the ratios of the 6 trigonometric functions based on whatever situations we're given. Okay. All right. So I've got a new angle, terminal side of angle theta in standard position, passes through the point -3, -4. Find the values of the 6 trigonometric functions. So it's the same thing, but now we've got a little bit more rotation. So we have our terminal side extending in quadrant 3. Okay. So we've got our ordered pair at -3, -4, x value -3, y value -4. We use our Pythagorean theorem. That's how we get our radius. Notice how our radius is still positive 5. Radius has to be positive. Okay? Which means you need to be really careful with the signs on your. Some will be positive, some will be negative. So as we move outside of quadrant 1, our first one was in quadrant 1, everything was positive, easy. But once we move into quadrant 3, 4, 2, 3, and 4, then the signs are going to change. So we need to pay really close attention to what's positive and what's negative. Okay? So what's my value of x? -3. What's my value of y? And what is my radius? 5. Okay? So I've got x, y, and r. I want you to go ahead and find on your own sine, cosine, and tangent. Give me the ratios for those 3 trig functions, sine, cosine, and tangent. Just those 3, and then we'll do the next ones after we do that. If you want to do all 6, you can. I'm going to pause in a minute and do those 3, and then we'll write them. Alright, what's sine of theta going to be? Yep. 4 over 5. Cosine of theta? 3 over 5. Tangent? Close. 4 over 3. Since they're both negative, our final one will be positive. Okay? What is the reciprocal of sine? So, say that again. Cosecant. Cosecant. And so then the value of cosecant is going to be, yeah, so we can just make it -4, -5 over 4. The location of that negative doesn't matter. It's going to be the same value either way. Putting it in the denominator. What's the reciprocal of cosine? What function? Secant. Secant of theta, -5 over 3. And what's the reciprocal for tangent? What function? Cotangent. 3 over 4. Okay? So when you have -4 over -3, whenever you divide a negative by negative, you get positive. Okay? And so that's what I was saying, be really careful with your signs. Sine, cosine, cosecant, and secant will all be negative, but because we're in quadrant 3, tangent and cotangent will be positive. Okay? And you'll find that to be true for every angle in quadrant 3. The signs of the functions will be consistent within each quadrant. So every time we find a sign value in quadrant 1, they're all going to be positive. But every time we find a sign value in quadrant 3, it's always going to be negative, because y is always negative, or y is always positive. Does that make sense? Okay? All right, so now we're looking at quadrantal angles. I can't draw triangles with these because they are on my axes. Okay, quadrantal angles are angles that are either 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees, or any iteration of those as we go around the circle. So they end, the terminal side ends on an axis. So we can't go back to that initial idea of opposite over adjacent because I can't form a triangle with my x-axis. Okay, so we have to remember the y's, the x's, and the r's. Okay, so looking at this point, let's identify x, y, and r.
X, 0, y, r, 1.
Good. How'd you get a radius of 1?
Plus 1 squared.
Okay. So, got my point 0, 1, x and y, easy enough. Radius is the square root of x squared plus y squared, 0 squared plus 1 squared, the square root of 1 for 1. But also we can even think of it in simpler terms with radius. Radius measures distance from center. If I'm going straight up the y-axis, how far are those 2 points from each other? 1. Okay? So there's my radius. Alright? So now that I've got my 3 pieces of information, we can go ahead and find sine, cosine, and tangent, right? What's my ratio for sine going to be? I don't know where the end went. Whoop, there we go. Okay? 1 over 1, which is just 1, right? Okay? Cosine. X over r, 0 over 1, which equals what? 0. And tangent. 1 over 0. Not 1. Not 0. Undefined. Okay? So now we have a value that's undefined. Tangent is undefined at 90 degrees. Quick little drawing time. The graph of sine is a wave. Okay? And it oscillates back and forth. Cosine does the same thing, it just starts at a different point. Okay? So sine and cosine both have that wave, they're continuous, it does that forever in both directions. But tangent, because we have these portions where tangent's undefined, whenever I draw tangent, I get this little sideways S, and then I have a jump, and it starts back up again. So at those asymptotes, that jump, that's where tangent is undefined, and then we kind of continue in that pattern. Okay? So now I've got those functions, I can go into my reciprocals. Reciprocal function for sine is which one again? Cosecant. Good. What's the reciprocal of 1? What? Reciprocal function for cosine is secant. And since the reciprocal of 0 over 1 is 1 over 0, now secant is undefined. So when cosine is 0, secant is undefined. Now when tangent is undefined, what is cotangent going to be? 0. If sine was 0, what would cosecant be?
1. Wait.
If sine was 0, what would cosecant be? Because when cosine is 0, secant's undefined. When cotangent's 0, tangent's undefined. If sine is 0, then cosecant will be undefined. Now, Fun fact. You could use any point on this line and still get the same answer. We could have done all of that with the point 0, 2. And we would get the exact same answers because we would have 2 over 2, which equals 1. And we have 0 over 2, which is 0. And 2 over 0, which is still undefined. So we can use any point on that line in order to find our ratios. Okay, we'll still get the same value because the ratios will just simplify. Okay, what's the measure of that angle? 180 degrees. Okay, so now we're using the point -3, 0. I could also use the point -1, 0, or -2, 0, or -100, 0. Doesn't matter. Any point on that line, on that terminal side, is going to give me the correct ratios. It's just a matter of how it simplifies. What's my x value? What's my y value? What's my radius? It's 3. You can use Pythagorean theorem and also just look that, hey, this point is 1, 2, 3 units from 0. I guess it's 0 to 3. Okay? On your own, go ahead and find all 6 trigonometric functions for theta. Yes. Yep. Greek letter theta. The trig functions sine, cosine, and tangent are nothing on their own without either an angle measurement or the letter theta. They're not an operation, or they don't have a value on their own. All right, what do we get for sine?
0.
0. What do we get for cosine? -1. Good. What do we get for tangent?
0.
0. Cosecant.
Undefined.
Secant. And cotangent. Easy stuff, right? It's just going to be a matter of remembering the ratios. That's what it's going to come down to, is remembering the ratios for sine, y over the radius, cosine, x over the radius, tangent, y over x, and then their reciprocals. And again, making sure that you properly match up sine and cosecant, and cosine and secant, and tangent and cotangent. Okay, making sure that you get those matched up. Okay, any questions on that? All right, a couple other things I want to go over real quick. So we saw this with our undefined functions. The y-axis, tangent and secant are going to be undefined, but on the x-axis, cotangent and cosecant are the ones that are going to be undefined. All right. There's a reoccurring pattern with all the trig ratios. There's not a lot of individuality with them, especially with the quadrantal angles. So for 0, 90, 180, 270, 360, and then all the way around and around and around, it's a repeating pattern, and it's all either 0, 1, -1, or undefined. Okay, those are those values. And then there's a lot of really common angles that we're going to see with special right triangles in the next chapter. And so you're going to see a lot of repetition in the values of sine and cosine and tangent and secant and cosecant and cotangent. There's a small group of numbers that repeat over and over and over, and then for some of them we just slap some negative signs on. Okay? Notice how for 0 degrees and 36 degrees, those rows are the same. Why? Yeah, they're coterminal. They're in the same place. If I've got my coordinate grid and I start at 0 degrees, no rotation, and go around to 360, well, now I'm in the same place. So all the trig values are going to be the same. Okay? If I kept going and I went to 450 degrees, 450 degrees is going to be the same as which of these angles? 90. So if I want to know tangent of 450 degrees, it would also be undefined, just like tangent of 90 degrees is. Okay, so there's a lot of repetition. We're very limited in the outputs that we're going to get. Now, for now, we're not going to be using our calculator a ton, but if you notice that you do sine, cosine of 90 degrees, you get those corresponding values that we saw, 1 and 0. If you try to do tangent of 90 degrees, it gives you an error for domain because it's undefined. It's not in the domain. Okay? Now, when we are doing using our calculator, one of the most common errors is that our calculator is set in the wrong mode. For our purposes, we're pretty much going to be exclusively in degrees. So when you look at your calculator, at the top, it should say degree. Okay? If it says radian, or depending on your model, sometimes it'll say DEG or RAD. You want it in degrees mode. And so if you ever need to change it, you can go into mode and just scroll down to where it says radians degrees and make sure you have degrees highlighted. Okay? Because you can find sine of 90 degrees and you can find sine of 90 radians, and those are going to be two very different answers. So you need to make sure your calculator is in the correct mode. I cannot tell you how many people I've had that they finished an exam and like, well, my calculator was in radians the whole time. And I need to be in degrees. So make sure your calculator is in the right mode. That'll make your life a whole lot easier.